Okay, so we're going to be learning a little bit about triangles in here. And so what I thought I'd do is maybe construct a couple of triangles. Now I'm going to want you to maybe make a triangle too. You can go ahead and kind of make them now. You're going to find me jumping around a little bit. But these triangles that I'm going to make, I'm just going to make about 3 of them. And then what I'm going to do is I'm going to cut them out with a piece of paper, and we're going to look at them. Okay, so there's one triangle there. Let me make one that's like different this way. I'm going to make a big, this one we'll call an obtuse triangle, right? And that one would be, I think that one's acute, right? We don't have, oh, that one might be bigger than 90 degrees. So I'll make a real, clearly what's an acute triangle next. But you can see me just making these triangles here. So let's see. And we're going to, let me make one about like that. And this will hopefully be acute. So here I have 3 different triangles. Okay, I'm going to now take a moment, I'll cut them out, and I'll show you where we're going with this, okay? Okay, so now we have our 3 triangles, and what I've done after I've cut them out is I've kind of marked them 1, 2, and 3 in each of these corners. 1, 2, and 3. I don't know if you can see that or not, but 1, 2, and 3. And now I'm going to do something that I hate to do actually, because these are nice little triangles, but I am going to cut them apart into pieces. So I'm taking my first triangle here, and I'm going to cut off angle 1, and I'm going to cut off angle 3, and that leaves me with angle 2. Now what I'm going to do is I'm going to come over here, and remember this 1 was the one corner of the triangle. So let's see if this can be, what if I line that right up there with that side? What if I line that straight up together? And then if I took angle 3, what happened if I line that up too, so that they all 3 met exactly at a point? Well, what's kind of interesting about that, you might notice, if I take those 3 angles of the triangle, what do they form? Together, they fill in every part of one side of a line, right? And if you they actually match up perfectly. I wonder if that'll work with the other triangles. Well, something tells me it does, but we're going to go ahead and do those real quick too. So I will cut off angle 1 and cut off angle 3. And I'll place angle 2 in the middle, put angle 1 on one side of it, and angle 3 on the other side of it. I'm just going to slide that up there. You can see that they are going to also perfectly fit together to form a line, okay, to come up straight on this line. And of course here's a third, different type of an angle here, or triangle here, so we're going to do the same thing. Goodbye angle 3 and goodbye angle 1. So we're going to put angle 2 right in there. Bring angle 1, we'll flip that back over. So that was our angle 1 right in there. Wait a minute, how did we have that? Was it like this? Angle 1. That might have been it. Angle 3. I'm not so sure now. Oh boy, I should have watched closer, huh? Try angle 1 this way. Maybe angle 1 was this corner. Yeah, angle 1, 2, and 3, and they fit together like that. And what you're going to see is that together, the 3 angles of any triangle come together, can be pieced together like we just did, put them together, to form a single line, to form a straight line and piece together to form that straight line. So now let's talk about lines. What is the measure of a line? How many degrees does that measure? Well, we can look at our protractor here. If we start at 0 and we go all the way around to the other side of that line, that's halfway around a circle. So it's 180 degrees. Half of a circle is 180 degrees. So if I take any three of these parts of the triangles and I measure each of those angles together, they're going to add up to how many degrees? Think about that. And they always add up to how many degrees? Well, it turns out they're going to add up to 360 degrees. And now I'm going to show you why that is. Okay, so now I'm going to, talk a little bit about lines. Let's take a look at these lines. Here's a line, and what I want to do is I want to construct a line parallel to it. So I'm going to be parallel to this line, and we'll just put it up there, say at point C. So what happens is, if I were to let's say I put a line through that parallel line. So let's say there was a line that went through that pair of parallel lines. Well, what happens here is that we actually have, I'm going to mark these intersection points. So let's find the point where these two intersect and the points where these two intersect right there. What happens is you have a special set of pairs of angles, okay? So the first set I'm going to talk about is corresponding angles. So the angles that correspond, let's go ahead and measure them. This is how we, this one right here is how we measure angles. So we're going to go ahead and, no, that's the reflection tool. Let me go back here. Yeah, sorry. Here's how we measure our angles. So what does this angle measure right here? Well, it measures, it might be hard to see that, but it turns out it measures 113.74 degrees. How about what angle corresponds to it? Well, the corresponding angle, you have to kind of imagine you're driving into town this direction in a car, and over here on the right, you're coming up to a light. This will be another intersection here. And over here, let's say it's a stop sign here. Well, this is where the corner where they would put the stop sign. So now you pass through that intersection, you come down, here's another intersection. Which corner would they put the stop sign on? On the corresponding corner right here. So we can measure our angle here that corresponds to the same intersection in the same way as the other one does. Take a look at it there. So these are corresponding angles. Now an interesting thing happens. If I move the line, it doesn't how I move it. You can see those angles are always congruent. They're always congruent. Right? No matter how I cut across that intersection, they're always congruent. You see what happened here? It's measuring the exterior angle here, and this is still an interior angle. So it kind of looks funny, but it turns out that as long as we're measuring the same angle the same way, they're always going to measure the same, right? How about our next pairs of angles? So let's do a little bit of this. Let's measure, these are called alternate interior angles. So we're going to measure some alternate interiors. So this one is angle CFG, okay, and you can see that one measures 66.26 degrees. So guess what our alternate interior angle kind of looks the same if you look at it, right? And it turns out that if we measure it, that it does measure exactly the same. You can see it there, okay? So this is what we have, alternate interior angles. And again, if I change this, as this angle gets smaller and tighter, so does that one, right? And as it gets wider and wider and wider, oh boy. When we get past 90 degrees, it's measuring, because it's measuring from point C. Actually, what I need to do is like maybe slide C over there, and then we can measure this way, see? You can see that as I get more obtuse, all right, it doesn't matter, that angle still measures the same, always measures the same. It always measures the same, okay? So that's a special pair of angles called alternate interior angles, and they always measure the same. So that is actually what we're going to need right now. I'm going to stop right there. That's a little bit of an overview of maybe some more angles we're going to see later on. But the key you're going to want to learn is how these angles are important. Okay, so let's take these apart and we'll show you something else. Ready? And I'm going to just take those angles out. Let's get rid of that line. Okay, we're going to get rid of that line. Now let's form, okay, a triangle from here to there, and back inside. So now, if I had a triangle and somebody said, well, how do you know? Remember we talked about that all these angles add together to 180 degrees. If we tear them off and we put them together, we can line them up in such a way that they always form 180 degrees. Well, how do we know that? Well, it turns out that this angle here measures, well, it's going to turn out this angle actually measures the same as that angle. Why? Because this is our little transversal line, right? Our line that comes through, and these are alternate interior angles of it. So let's take a look at that real quick. We'll measure this angle here. I got to place another point on, so let me place a point over here on. Oh boy, that didn't work. Sorry. I'll place a point over here on, and a point over here on. Okay, and now let's measure our interior angles. Are we ready? Using our angle tool. So we're measuring, oh boy, I may hit escape. I want to measure the other angle the other way. We go from here to there, down inside there, and you can see that angle right there measures 49.38 degrees. Now this is an alternate interior angle, a special angle pair. So if we measure that, got that one backwards again. Let's try it again. Let's start here. The alternate interior angle is BAC, and you can see that it also measures 49.38 degrees. So this measures exactly the same as that one, right? And so now if we were to guess this angle here, it's definitely going to measure the same as that one. And here we go. We'll measure those angles right now. So we have BCE. That one is 37.55, and AB. Oh boy, let's try the other way. Sorry, I kind of forget these sometimes. So CBA also measures, you can see, 37.55 degrees. Okay, now that's going to be true even if I move point C and change all those angles. It doesn't really matter, right? How that triangle is shaped, those angles are always the same. Okay, doesn't matter where I move it to. So what that means is that they always are going to equal 180 degrees. So somebody said, how could you prove that the three angles of a triangle, the inside angles of a triangle, so that's this angle here plus this angle here and plus this angle here, how would you prove that they add up to 180 degrees? That's a theorem called the triangle sum theorem. Well, what would we need to do? What I would do is I would draw a transversal, or I would draw a parallel line that goes through point C. It's parallel to the opposite side, and it goes through this vertex. And then I would say this angle here and this angle have to be the same because they're alternate interiors. This angle and this angle have to be the same because they're alternate interiors. And because these two are opposite rays, right, all together these angles can be added up and they're going to equal 180 degrees. So that's really my proof. Right? If these equal 180 degrees and these two are the same, then I can substitute this angle beta for that angle alpha, etc. And I can substitute these angles in because they're going to always be the same. And so together, if I add this, this, and this, they equal 180. By substitution, I can add this, this, and this, and they'll equal 180. And that's my proof.